Hey everyone, today we're going to finish the very last section of this chapter and we're going to relate free energy and temperature now. So calculating delta G of the standard form using the thermodynamic quantity help sheet makes it possible to calculate the delta G for standard temperature reactions. So those reactions are going to be the ones at 25 degrees Celsius, otherwise known as 298 Kelvin. However, we can't always keep temperature at 25 degrees Celsius, and maybe we're interested in examining them at other temperatures as well. Well, this section, we're going to learn how to take other temperatures and examine and predict what's going to happen. So in this section, we're going to still use that following equation that we've already been doing. Delta G equals delta H minus T delta S. Now, our delta H is our enthalpy term, so this is going to be our heat of our system. And then our negative T delta S is our entropy term. This slide right here summarizes everything that we've been learning, not only last chapter, but this one as well. For example, delta H is the enthalpy term. Again, remember this is going to be your heat. If the value is positive, it's going to tell us that our reaction is endothermic, or in other words, absorbs heat or energy. If it is negative, that's going to tell me it's exothermic, and this is going to release heat or energy. The second term we learned was this delta S value, and that is our entropy term. Now, the reason we are able to attach it to that negative T is because T is always positive at all temperatures. Because the unit is in Kelvin, the lowest Kelvin can go is absolute zero. So that's the only time it would not be positive. But it's not negative either. So if we want to look at it, we can look at entropy value two ways. You can look at just the delta S value. If that is positive, we have more randomness. If it is negative, it is less randomness. The other value you can look at is that negative T delta S. If you look at that value, it's going to be the opposite of what you think. If you have a negative value for negative T delta S, that's going to be greater randomness. Or if you have a positive value, that's going to be less randomness. And then delta G stands for Gibbs free energy. It's going to tell me my spontaneity. So remember, G stands for Gibbs free energy. Gibbs free energy is going to depend on the signs, which means positive or negative, and the magnitudes, so if it's a low number or high number, of your enthalpy and entropy values. For example, if delta G is positive, that's going to tell us that my reaction is non-spontaneous, and if delta G is negative, it is spontaneous. This entire slide summarizes a whole bunch, so it's a very nice slide to write down. Here, this is a picture, but I'm going to go ahead and start it. Take this picture with your phone, write this picture down in your notes. I will give it to you on your homework, so the easiest thing is to make sure you take a picture of it somehow or write it down. This tells you and allows you to identify what would happen for a reaction if you increased or decreased temperatures. Would it be classified as spontaneous or non-spontaneous? The two values that you can easily look at is your delta H value and your delta S value. For example, if your delta H was negative and your delta S was positive, all your reactions are spontaneous at all temperatures. Whereas if it was the opposite and delta H was positive and delta S was negative, that means you're non-spontaneous at all temperatures. If they are both negative or they are both positive, it's going to depend on what temperature it's at to tell whether it's going to be spontaneous or not. So let's go ahead and get started. So delta G is temperature dependent. Usually delta H and delta S change very little with temperature, so we like to assume that they don't change with temperature at all. And again, we'll use the following equation we have been using, that delta G equals delta H minus T delta S. Well, we can just go ahead and replace our T that we've been using to solve for this and actually determine what delta G is going to be at two different temps. Before we get started, I want to first predict, based on my delta H values and my delta S values, what is going to happen if I increase temp. So here my delta H value is negative. Here my delta S value is negative. So if both values are negative, what does that mean? Let's go back and look at our chart. Here, if both delta H and delta S are negative, we should expect to see our reaction be spontaneous at low temps and non-spontaneous at high. So again, we expect to see spontaneous at low temp and non-spontaneous at high temp. That's how you would classify your reaction based on those two values. Let's see if that's actually true. So the first thing we need to do is make sure everything is in its proper units. Remember, our equation is delta G equals delta H minus T delta S, where T has to be in Kelvin. So here and here, in order to change these to Kelvin, you need to add 273 to both of them. From here, you would get 298 Kelvin, and over here, you would get 703 Kelvin. The other thing you have to make sure is in the appropriate units is just like the last section, your delta H is in kilojoules, your delta S is in joules, so we need to change your delta S value. So if your delta S is negative 198.3 joules for Kelvin, in order to change joules into kilojoules, you guys are going to divide by 1,000. And that gets you negative 0.1983 kilojoules. Then you can go ahead and plug those into your equation. So first one we're going to solve for is 25 degrees Celsius, and the second we're going to solve for is 500 degrees Celsius. So here we don't know G, so we put an X. Our H value is negative 92.38. Minus, and here's where you plug in your temperature. So remember, you have to plug in the Kelvin one. Here you're going to plug in 298. Well, down here you're going to plug in 773. From there, you're going to plug in your S value, which we found over here, negative 0.1983. Negative 0.1983. Then you can just throw in your calculator and solve. So for 25 degrees Celsius, if you follow your order of operations, multiply, then subtract, and you get negative negative 33.2866 kilojoules. Down here below, multiply first and then subtract. You get 60.9059 kilojoules. And so those are your two values, and you found your answer. Now, does this match up with what we predicted? Yes. We're notice at 25, which is considered a low temperature. We are spontaneous because this value is negative. Whereas if we increase temperatures to 773, this is considered a high temp, and this shows that since this is a positive value, this is non-spontaneous. So here's a problem I want you guys to try on your own. First, look at your delta H and delta S values and see if you can predict what do you think is going to happen if you heat up this temperature. So now that you've kind of looked at it, let's kind of discuss it. Here you have a negative number. Here you have a negative number. So just like the last problem, these are going to be spontaneous at low temp and non-spontaneous at high temp. Next thing you have to do is make sure everything's in your proper units. So here, my temperatures are already in Kelvin. I do not have to worry about that. However, my entropy is given in J, my Enthalpy is given in kilojoules. So I have to change my joules into kilojoules. So here my delta S value for negative 189.6 joules per Kelvin. We got to divide by 1,000, and that gets us negative 0.1896. From there, we can go ahead and plug into our temperature. So first we're going to solve for 298 Kelvin, and we're also going to solve for 400 Kelvin. So if we remember our equation is delta G equals delta H minus T delta S. My delta G value I don't know for either one, so X. My delta H is negative 196.6 minus temperature. So my temp in the first one is 298. My temp in my second one is 400. And then we're multiplying these by your delta S value, which your delta S value we found down here to be negative 0.1896. When you go ahead and find this, you're going to find 298 to be negative 140.0992 kilojoules. And then the bottom one is negative 120.76 kilojoules. So how did you do? Did you get those values? Okay, now let's kind of compare those values to what we predicted. We predicted that it's going to be spontaneous at low temp. Both of these values are negative, so both of these are going to be spontaneous. Even this one is spontaneous, which means 298 and 400 are considered to be low temps. One way to double check that it's going to be non-spontaneous at high temp is notice that as I increase the temperature, the closer this value is going to get to 0. You can also double check yourself by picking a high temp. For example, 1200 Kelvin is a very high temp, and if I plug in my values, and just substitute 1200 in for temp, you're going to see you're going to get 30.92 kilojoules. This is now a positive value, which means it's non-spontaneous at that very high temp. So what we've guessed has held true. Anyways, let me know if you have any questions or any issues. That's the very end of the lesson. It's very simple. You've done these problems before. Now you're just plugging in a different temperature for them. So again, let me know if you have any questions, and I'll be more than happy to help. Have a good day.